Right. Lecture 5, Velocity-Time Graphs.
So from 1 to 7 is the homework?
Yep. I don't think it'll take you that long to do.
Is it all the similar questions?
Did I make them all similar? It gets a little bit more interesting towards the end, especially number 7. I like number 7. Look at it, it's wonderful. There's a block on a wedge. Okay, let's see. Presentation. Right, next lesson. Oh look, the black line is mysteriously gone. Velocity-time graphs. Got that? Velocity-time graphs. What are you doing in maths class at the moment? What was your last lesson about? Quadratics. Surds.
Yeah. Quadratic.
Alright. Continue. Yeah.
What
Now.
was the lesson called?
Oh, there we go. Velocity-time graphs. Okay. So, before we start, something called a sign convention. So, in one dimension, positive means right and negative means left. So, if I say, let's say, oops, upside down. If I say his velocity equals 3 meters per second, you might say, well, no, that's not velocity, that's a speed, because there's no direction. But the direction is actually in the sign, because the plus will mean to the right, and the minus will mean to the left. So it is a velocity, the direction is in the sign. So the rule is, right is positive, and left means, is meant by negative. And up is positive and down is negative. Now, you can swap them. You can say down is positive and up is negative. That's okay. But you must do that for the whole question. Okay? I don't like doing this. I prefer to stick with positive, positive, negative, negative. Okay? So, right is positive, left is negative, positive is up vertically, and negative vertically is down. Okay? It's just like maths class, you know, with your x and your y. It's the same. So we just call this the sign convention. Now, does anyone know what the word convention means? Anyone know? No? So convention is it's like a rule, but you don't have to do it. You know? Like, for example, in Ireland we drive on the left or the right. Which side of the road?
Either end.
On the left here, yeah. That's a rule, not a convention, because can you choose to drive on the right? No. Okay? So let me think, what might be a convention here in Ireland as an example? Yes, when you get off the bus, you thank the driver. That's not a rule, it's a convention. Okay? You cannot do it and you can do it, but most people do it. So it's a convention. Okay. So S equals 1 meter. That means 1 meter to the right. And S equals minus 1 meter, 1 meter to the left. I think that's okay, isn't it? It's all right. Okay, so now our first definition, acceleration. Now, does anyone know what acceleration is? The definition.
How fast it gets to its speed?
Close. Just need to fix the language a little bit. Acceleration, does anyone know? Acceleration is the rate of change of velocity. So as a formula, it's the change in velocity over the change in time. So the units I want you to figure out. So tell me what the units are.
For
Acceleration.
Meters per second.
Meters per second squared, yeah. Because if you look at it like this, on the top you have velocity, which is meters per second, and on the bottom you have seconds, so it's meters per second, or in other words, meters per second squared. Yeah? Have you seen acceleration before, maybe? So yeah, it is, like you said, it's how quickly the speed changes. So when you're driving a car, when you put your foot down on the pedal, you accelerate. So accelerate means to go faster, increase your speed, change your speed, change your velocity rather. Okay, so you know this could be an exam definition. What is acceleration? So you could just say acceleration is the rate of change of velocity per unit time, and as a formula, it's this. In the exam, they don't need both. They either need the sentence or the formula. But if you give the formula, you have to explain the parts of the formula. So you'd have to explain delta V represents the change in velocity and delta T represents the time that has passed.
So it's like rephrasing, yeah.
Yeah, it is. It is, yeah. Okay, continue. Yeah? Okay. Now, some naming convention. And again, it's convention, not a rule. So the letter U, does anyone know what this represents?
Velocity 1.
Yeah, velocity 1. What's another, rather than saying velocity 1, can you give me an adjective? There's something velocity.
Sorry.
I'll make it a bit more academic. More academic than that. There we go. The initial velocity. The velocity at the beginning, also known as the initial velocity. Okay. The next one is V, which represents
Velocity.
the end velocity, yeah. Final velocity, yeah. A is obviously going to be acceleration. T is obviously time from going from U to V. And finally S is displacement, which is position. So it's where the end is compared to where the start is. So in other words, where it finished compared to where it started. So UVATS. Yeah?
So you can say velocity is V minus U.
Delta, change in velocity, V minus U, yeah, delta V. Okay, continue. So let's have a look at a simple example. So, you know this fella, Usain Bolt, fastest man alive. Oh, isn't he a footballer now?
Is it?
Yeah, I think he should.
He wants to get into football.
He wants to get into football, yeah. Change of career. Anyways, let's look at the UVATS. So, what would the U be for this little Olympic achievement? What would the U be? Well, yeah, so it would be 0. It would be 0. Because everybody starts at rest. Okay. What would the V be? Now, just roughly estimate what would the V be. Now, we'll skip the V. We'll do something a little easier first. What's the T, roughly?
Time.
Yeah. Which is what?
9 seconds.
Oh, I don't think he's that fast. What was it? He's not that slow. Yeah, it's about like 9.65 or something. 9.65. Yeah, that's the T. Okay, well, what's the S? The S is 100 meters. Obviously, that's the name of the race. 100 meters. What do we say the V is roughly? Yeah, how many meters per second do you think he's running at the end? What do you think the speed is he reached at the end? Is it going to be 1 meter per second? No, it's a bit slow, isn't it? What do you think it might be? You're thinking maybe 10 meters per second, 11? Yeah, I think it might be as much as, it might even be as much as like 12 or 13 meters per second is the V. Yeah, and I don't know what the A is, the acceleration. So I just did this because I want you just to understand the UVATS. Okay, the U is at the start, the V is at the end, the S is the displacement, the T is the time, and the A is the acceleration. Okay, so just remember, velocity can be positive or negative because it's a vector, but speed is only positive. Displacement can be positive or negative because it's a position. You know, you can be 1 meter or you could be minus 1 meter. But distance can only be positive. Do not confuse speed and velocity or distance and displacement. Now you know this is important because I put in red with the word warning on the top. Okay, so just to be careful about this. You obviously don't need to write every single word. The key point here is do not confuse speed and velocity or distance and displacement. Yeah, because speed is positive, velocity is positive, negative, distance is positive, displacement is positive or negative. Okay. You made some note of your warning? Yeah. Continue? Yep. Okay. Now, it's true most of the time the speed and velocity and the distance and displacement are the same, but not always. Not always. You've been warned anyways. Okay. So, we're going to have a look at a graph now called the Velocity-Time Graph. And it's quite simple. On the X is time, and on the Y is velocity. Okay? And we imagine a little story here, and the graph is telling us what's happening. So you're driving in your car. You get faster and faster quite slowly. So we say we accelerate slowly. Okay, so maybe you drive out of your house and you're slowly getting faster and faster, slowly. So that's accelerate slowly. Now, what do you think happened here? The speed, the velocity suddenly increases. You accelerate quickly.
Accelerated.
Yeah, why? What might have happened in the story? Yeah, maybe you got on the motorway, the highway.
More pressure on the pedal.
Put your foot down on the pedal, yeah. But now here the velocity is constant. So what do you think has happened here?
It doesn't want to exceed the speed.
Yeah, speed limit. 120 kilometers an hour, speed limit. And then slow down rapidly.
Stop light.
Well, not on the motorway.
Car.
Yeah, maybe. We'll say a student stepped in front of the car. Okay, so you decelerate. You slow down quickly. What's happening here? Stopped. Yeah. What's happening here? Reverse, to run over the student that you missed. Correct. And then here, you're still reversing, but at a constant speed.
Okay.
Yeah. So what I'm trying to say is the velocity time graph has a lot of information in it. It can really reveal what's happening. Okay. And what's important here is some of the words. So here, accelerate slowly, accelerate quickly, steady speed, slows down, rapid deceleration. Deceleration means slowing down. Stopped, speeds up in the opposite direction, or as you said, reversed. Steady speed in the opposite direction, so that would be reversing. Yeah. So what's important here is the vocabulary. I would like you to draw this with the words. Can you see the words okay, actually? Oh, I think I should make it a little bit bigger next. Well, I'll do it later. You got all the words down? Oh, great. It's too small, is it? Here, I'll try and make it a little bit bigger. Oh yeah, that's fine, that's fine. One moment, let me close this and reopen it. I'll at least make it a little bit bigger. Loading. Still loading. There we go. The heck? Open it up. It's a little bigger, So do you want to take a picture? Yeah. You know this is on YouTube as well. Okay, will we continue after this? You have this? Yeah? Will I continue or do you need to? Yeah? Okay, so next now. Matt, it's okay? Yeah? Okay. So here's a little example. A car starts from rest, it slowly accelerates to 20 over 10 seconds. It continues at this speed for 5 seconds and then suddenly, before suddenly decelerating to rest in 4 seconds. I want you to try and draw the graph of this story. Try and make the graph here. I want you to draw this.
We need to label the exam, right?
Huh?
We need to label it.
Oh yeah. Okay, have we drawn this? Yeah, yeah. Yeah.
The scaling nothing?
If it's a sketch, nah. I mean,
Like
yeah, don't be like ridiculous and make like the 2 seconds bigger than the 10 seconds, but unless
like on the y-axis, because here's 20 and here's 10 all the way.
oh no,
That's
no,
fine.
that's fine, yeah. Okay, let's draw this now, yeah? So this here is time in seconds, and this one here is velocity in meters per second. Okay, so what happens, it starts at rest and then accelerates up to 20 meters per second in 10 seconds, and then it continues at this speed for how long? 5. So then this is the 15 mark, and then what happens, it decelerates in 4 seconds.
Nice.
Yeah, so that finishes up on 19 then. Yeah. Alright, that's okay, isn't it? Next, Dad's silly triangle from middle school. I'm sure you've seen this one, yeah. So you have this triangle which is quite useful. Distance, speed and time. So if you want distance, distance is speed multiplied time. If you want time, time is distance over speed. And if you want speed, speed is distance over time. Yeah? So this one triangle can tell you all of them. Have you seen this before in middle school or high school?
High school.
High school, okay, not middle school, high school. Huh? Maybe, okay. So if you can copy this down. Now, this triangle only works when the velocity is not changing, because these 3 numbers need to be constant. So a fixed distance, a fixed time, and a fixed speed. So it only works when the velocity is not changing. So in other words, you can only use this triangle if you have 0 acceleration. What do we do if the velocity changes from u to v? We'll find out shortly. But for now, I'll just tell you this triangle is only for 0 acceleration. Okay. Continue. Yeah. Right. I want you to use the triangle to answer this question. A boy walks 2 kilometers to school every morning. It takes him 30 minutes to walk this journey. What is his speed? And you can assume it's constant. That is, he doesn't walk faster or slower. He walks at a constant speed. So, using Dad's silly triangle, what is his speed? I would like it in meters per second. So I want the speed. Sounds believable speed. So what did you type in?
2 over 1,800 and then multiply it by 1,000.
Okay. I would have typed it in as 2,000 over 1,800. Yeah. Same thing though. So what was that?
1.1.
Okay. 1.1. You should get that. I'll show you on the calculator. Oh, I closed it. Let me reopen it. Did you get 1.1? Yeah. Did you get 1.1? Yeah. Kim? Yeah, you got it? Yeah. What did you type in on the calculator?
2000.
You did 2000, yeah, over
60 times 30.
60 times 30, good, okay. Where's it gone? Come on. Anyway, so what formula am I'm looking for speed. So speed is distance over time. Speed is distance over time, which is 2,000 meters over 1,800 seconds. So 2,000 over 1,800, so that is 1.11 meters per second. Is that okay? Yeah? You might be thinking that velocity time graphs can tell us velocity. True. But it actually can tell us much, much more. Let us see. So there's actually a lot of information on the graph. I'll show you now. So, this is time in seconds. And this one here is velocity in meters per second. This is time. Okay. So let's think about this. Here's a car. It starts here, travels, and finishes here. So this is the velocity at the beginning, isn't it? So actually we can call this what letter? U. And this is the velocity at the end. So we can call this one here V. Here. Okay? What would this be? T. Yeah? Okay. Now, continuing. This point here would be the point T, comma, V. Yeah? And what would this one be?
T, comma, 0.
0, yeah, comma, U. Yeah? Now, in math class, did you do this? Slope.
Mm-hmm.
And what's the formula for slope? y2, yeah, y2 minus y1 over x2 minus x1. In this case, what would that be?
V minus U.
Yeah.
Over T minus 0.
Yeah, which would be the change in the velocity, which is delta V, over,
Given, right?
yeah, they would be given, yeah. Change in velocity over the time.
Mm-hmm.
But what's that? Acceleration. So in other words, the slope is the acceleration. And lastly, let's have a look at what the area represents. Okay? Let's look at the units. So, what units is the horizontal in? What units is the x-axis in? Seconds, isn't it? And what is the y-axis in? Meters per second. So what would the area be in? Well, it'd be in meters per second multiplied by seconds. Would it? Because this is like m over s times s.
Also, it would only be meters.
Yeah, so what does meters represent? Distance. So the area is equal to the s. So the graph can tell us u, v, a, t, and s. That's why it's so useful. So to summarize, u is the height at the beginning, v is the height at the end, a is the slope, the gradient, t is the length of the base, and s is the area. So everything is contained on the graph. Okay. So obviously you need to make note of this. You got that? Yeah? Continue? Continue? Yeah? Okay. So let's have a look at an example. Here is time and velocity for a car. So you see the car starts at 0, then increases to 20, stays at 20, and then slows down to 5 meters per second. So first we want to plot this. Now, in the exam, plot means you draw it carefully on graph paper, which, actually, I suppose I could open up my office program to do it. Ah, no, I'm lazy. I'll just roughly draw it. Careful now. So I need to go up to 10. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds. Okay, and I need to go up to 20, so I'll go 5, 10, 15, 20. And this is velocity in meters per second. Okay, starts at 0, goes up to 5, goes up to 10, goes up to 15, and then 20, 20.
I'm just going to scroll one up.
Did I get it wrong? Oh, sorry, yeah. Thank you. Goes up to 20. So I'm up here, isn't it?
Mm-hmm.
And then
Stay.
stays another 20. And then, where am I at? 15, 10, 5, 5, 5. 15, 10, 5, 5, 5. Okay, I'll put some red in to have. So that's 5. That one is 10. That one there, they're 5s. They're 15s. And they're they're 20s. Okay. What is the distance, the acceleration, and the deceleration? Okay, so first part. How do I get the distance? Well, that's equal to the area. So how many shapes have I got here? Well, I think if I look at it, I've got a triangle. Yeah. A rectangle, a triangle, and a rectangle. So, a rectangle here, a rectangle here, a triangle here, and a triangle here. So the first one will be a half, 1, 2, 3, 4. So a half times 4 times 20 plus, this is 1 multiplied by 20, so that's 20, plus, now this one is plus a half times 3 times 5, 10, 15. The height of this one's 15. And the last one is 1, 2, 3, 4, 5. 5 times 5. Yeah, these are in 5s. So that's 25. So what's that? 2 times 20, isn't it? 40. Plus 20. Plus, goodness, 1.5 times 15. 22.5?
Yes.
Plus 25. So 60, 70, 85, 95, 107.5 meters. Tell me the good news. Am I right or am I wrong?
71.5.
No, couldn't be 70.
Yeah, I think maybe I calculated wrong.
You did 4 times 20, but you didn't divide it by 2. The half.
4 times 20 is 80, divided by 2 is 40. Am I okay or am I wrong? I can accept being wrong. It's, A half times 40 times 20 plus 20 plus a half times 3 times 15 plus 25. No, not correct. You got a totally different number. Oh, you typed in a half times 40. It's a half times 4.
Oh, okay.
I got 107.5. I'm afraid I think I'm right. Yeah. Sorry to disappoint you. B, the acceleration. Well, you can do acceleration as rise over run. So you can do this divided by this to get the acceleration, the A here. So that would be 20 over 4, which is 5. Have you seen this in maths?
Yeah.
Yeah. And then C, the deceleration, so the negative, would be 15 over 3. Oh, that's also 5, isn't it?
Yeah.
So that's 5 as well. Yeah, okay, can you write this one down? My picture now is a little messy. Beautiful. Okay, have we got this? I still see a bit of writing going on. You got this, Kim? You wrote this down? Yeah. Did you say you're computer science, or what were you going to study next year? Ah, aeronautical, yeah. Okay, can I continue? Yeah? Is it okay?
Should we read the question then?
What is that? You can get it from the YouTube video.
Oh.
Yeah. It's only one left. I'll do this one now. A mass can accelerate at 5 and decelerate at 6. If the car accelerates from rest and then decelerates to rest in 22 seconds, how far has the car travelled? So in this story, what's happening is this. Time, velocity. The car accelerates and decelerates. And it can accelerate at 5 and decelerate at 6. And the total time is 22 seconds. And I want the distance. So I want the S here. Alright. How can we do that? See, that's a little tricky. What do we think? Let's try and do this together. Let's see if we've got any ideas. So what could we do?
Divide into two triangles.
Yeah, I think that's a good start. We want to split it into 2 triangles, yeah. So that's a start. And maybe...
Would that be 11?
No, not necessarily, because they're not necessarily equal. In fact, I'd be surprised if they were. So, something else now.
It's right angle.
Yeah, it's a right angle, that's for sure, yeah.
So it's 11 and
Might not be 11. Might not be 11. What we can do perhaps is we can call this distance T1 and this one T2. Okay. Now, and I should give this letter a name, so let me just call it V. Okay. What would you say 5 equals, the acceleration? What's rise over run here? It would be V over T1. Yeah. And what would 6 equal? V over T2. Is that okay? Are you sure? So could I say V equals 5T1? Yeah. And could I say V equals 6T2? Could I say 5T1 equals 6T2? I could, because they're both equal to V. Yeah, this is equal to V and this is equal to V, so they're equal. So I could do this, couldn't I? Just make them equal to 0. So I'm trying to make a simultaneous equation, 2 equations. So is there another equation I can make with T1 and T2? Is there something else I know about T1 and T2?
5V1. 5U minus 6.
Very good. T1 plus T2 has to equal 22. Now, look at what I have. I have 2 equations with 2 unknowns. Have you done this in maths class yet? Yeah.
Elimination.
Good elimination. Yeah. You could solve this, couldn't you? And if you solve this one and you figured out the T1 and the T2, then you can figure easily out the V. And you can figure out whatever you want. Okay? Yeah, so I don't think I'll continue because the rest is kind of straightforward. So the next thing you would do is you would get T1, you would get T2, you could get V by using any of these, and then once you had V you could finally get S, because S would equal the area, which is a half the base by the height. Okay, so I think what I'll do is I'll let you finish this as an extra homework question with the 5 questions here. Okay, so if you want, oh actually no, there's 2 minutes left. I'll leave you the last 2 minutes to finish this, to write it down and to finish it.
And what is the homework?
Whatever the next one is. My number might be different. It's this one here. Yeah, that's it. Yeah. So use the last couple of minutes, please, to write this down and to finish it, and then the homework will be in the book. Yeah, it's not nice outside. Yeah? Did you finish it? What you get for T1 and T2? Huh? 12 and 10. Great. And what did you get for V? Wonderful. And S? Perfect. Okay, very good. So your homework then is on the next page. Tomorrow we'll do whatever you found difficult in the tutorial. Okay? Right. Can I close this? I can close this?
No.
Have you subscribed to me on YouTube?
Not yet.
That's terrible. Have you liked any of my videos?
I haven't used it.
Oh, that's outrageous.
I will.
Oh, sure. Yeah, you can go. We're finished. Yeah. I'm closing this.
Yes.
Yeah, if you said that we're gonna do an exam.